this is the small presentation of the question. So first of all, I'd like to go through the question. It was an easy problem, the question of problem A. So the problem stated that we have a m into n cross grid. So m into n cross grid, this you can see that this is a small representation of the grid. So there are m rows, just I have written 1 2 3 4 5, that's it. And c1 c2 c3 c4 c5. So these are 5 columns. So by the question itself, by the input, you can see that first line was n into m, the number of rows and columns, and in the second and the third line you will be given with the sum of the rows and columns. Suppose uh, r1 represents the summation of this row, the numbers of this row, r2 represent the summation of the numbers of this row, and similarly r3 r4 r5. And in here c1 c2 c3 c4 c5, I have demonstrated that the summation of the numbers of first column, the summation of the columns, the summation of the numbers of the second column, third and fourth and fifth. So now what is the main intention of our question, what we need to find out? So the main intention of the question is to find out whether a grid with such configurations, having such summation of the rows and such summation of the columns, is it possible or not? That is the question. On if it is not possible, we need to print out impossible. So thinking a bit, we can see that summation of the rows, if we sum, so I need to go to the logic. So this is a logic, right? Again I will go to the grid. So if we sum up r1 r2 r3 r4 r5, so we can see that r1 r2 r3 r4 r5, that means we have covered up whole numbers of the grid. Similarly c1 c2 c3 c4 c5, c1 c2 c3 c4 c5. Okay, we see that the summation of r1 to r5 and summation of c1 to c5 has to be equal, because this includes all the numbers of the whole grid. So the main logic is this: if such a grid of m into n cross has to exist, the summation of all the row sum and the summation of all the column sum has to be equal. So here it is, summation of all row sum, summation of all column sum. If it is true, either the summation of column sum or row sum that equals to the total sum of the grid. So as the question was asked, like you need to print out the summation of the whole grid. So either you print out the summation of all the rows or summation of all the columns. That's it. So if this condition is not fulfilled, if this condition is false, we can see that we can print out impossible. So this is a small screenshot of the code that I just like to share. So you can see that these are the header files, include main and nm. We have taken in the what to say, the number of rows and number of columns. So long sr and sc just represents the summation of rows, total summation of row sum and total summation of column sum. So this is the vector that will incorporate all the row sums r1 r2 r3 r4 r5, just like the grid. This is a sample problem. This is not a sample problem but a sample representation of the grid. So by the for loop, we see that we have taken in all the row sums. I'd like to say that don't get confused by row sums and summation of the row sums. In the question it is given row sums, and here by the code we are calculating the summation of row sums. That's what I mean to say. So sr is the summation of the row sums, and again by using the second for loop we are first of all we are taking in the input of the column sums, and again in the same for loop we are taking in the summation of the column sums. So this is the logic. Again I would like to say this is the logic. If SR is equal to SC, summation of row sums equal to summation of column sums, then we can print out SR or SC as both has to be equal. By this you can see SR equal to SC, or if it is not equal we can print out impossible. I hope it is clear. It was a fairly simple problem. This was a great problem. So with that I would like to conclude on A. I hope that there are no doubts.
Is my screen visible? Okay, then
Yeah, visible.
moving on to the second problem. This said that there was a police officer. He was asked to consider all contiguous, meaning continuous subarrays of length k, and for each such subarray, he had to find the maximum element. He sums up all those maximum elements and reports the cumulative sum. So, in the question, you were given the integer n, which represents the number of buildings, that is the length of the array, and an integer k, which represents the range length, and an integer array h, which represents the height of the buildings. So now if we consider this test case, when n was 10, which means the array length was 10, k was 5, and these were the array elements. Let's dive into the solution. Okay, so we took the inputs n, k and the array. Then we used a multiset. Why a multiset? Because multiset stores the elements in sorted order. So the first element of the multiset represents the smallest element and the last element represents the largest element. So to our answer, we were actually adding the last elements of the multiset while keeping the window size of the multiset to be k. Like for example, in this case, when the window size was k, when the window size was 5, for the first contiguous subarray of length 5, these were the elements. So we first inserted these elements into the multiset. So in the multiset, the elements were arranged in this fashion. The multiset stores all the elements in sorted manner. So the elements in the multiset were stored in this fashion. Now we initialized answer as 0, and then we added the last element of the multiset into the answer. R begin means the list started from the end, and this entirely meant we are considering only one element from the end. So to our answer, we first added 50 for the first contiguous subarray of length 5. Now from I equal to k till n, I equals to k was 5. So from the element which is in the fifth index till the last, we need to keep on adding the elements one by one. So when I is equal to k, we'll find area of k minus k, which is area of 0. We will find if this area of 0 exists in the multiset. So area of 0, this is 50. The 50 exists in the multiset. And if it does, we will remove this. We will remove area of 0. Why we are removing 50 is because when we are considering the next subarray of length 5, 50 will no ways be used to calculate the maximum of this subarray. So we can remove 50 and we can add 70. So here we are removing 50 and st.insert array I. This is inserting area of k, which is area of 5 into the multiset. This is in sorted fashion. So now we are adding the last element of this multiset into our answer. Now when I is k plus 1, which means I is equal to 6, we are considering we are considering this we are considering this subarray. So for this, we will find if area of k plus 1 minus k, which is area of 1, is present in the multiset. Area of 1 is 45, 45 is present in the multiset. We are removing it and we are adding area of 6, which is 10. 10 will automatically be added in the front in the multiset. This is stored in sorted order, and to the answer will again add 70. Now when I is equal to k plus 3, we'll find if area of k plus 3 minus k, which is area of 3, is present in the multiset. Oh no, when I is equal to k plus 2, which means area of 2, if area of 2 is present in the multiset. It does, so we are removing it and we are adding area of 7, which is 10. So even now the maximum element stays to be 70. Now when I is equal to k plus 3, which is 8, area of 8 minus 5, area of 3, 32 is present in the multiset. We are removing this and we are adding area of 8, which is 44 in the multiset. So even now the maximum element stays to be 70. So we are adding 70 to our answer. Now for the last iteration, when I is equal to k plus 4, we are finding if area of 4 is present in the multiset. 40, it does exist in the multiset. We are removing it and we are inserting array of 9 in the multiset, which is 84. 84 will be added at the last. So the maximum element here is 84. The answer is 414, and this is what we are outputting at the end here. Is this clear? I hope it is. Now we can move to the next question.
Am I audible? Hello. Okay, so before moving on to the next question, I would just like to like there was this solution by Pratinov. It got accepted, but it was a lag from our side. We didn't add the edge cases. Pratinov, are you there? So this is
Yes,
not
bhaiya.
just for him,
हाँ,
not just for him. This is for everybody. Like he used this approach. Like he first inputted the vector, then like basically he's running the for loop k times, getting the maximum out of them. Obviously, there's gonna be correct for the first iteration. Like you're gonna find the maximum of the first k elements. But after that, he ran it for n minus k plus one times, and this is the inner for loop. So can anybody tell me the worst case time complexity of his code? Just look at the code, especially this part. I'll be really glad if anybody can tell me the worst case time complexity. Okay, Pratinev, you only tell me what's going to be your worst case time complexity in terms of n and k.
yes, bhaiya. Worst case will be here n minus k for the lower loop and upper के लिए n minus k square type जाएगा शायद.
It will be n minus k into k. So like basically, if you're
अच्छा.
stuck in like finding out the time complexities, just write it mathematically. Like it will be n minus wait a second n minus k into k. Okay, so like how do you find the worst case time complexity of this term? So the simple way to do it is just like you all have studied class 11, 12, and even in class 10 for some people. Like we know the property am is greater than equals to gm, right? So if you take the arithmetic mean of this, what's going to be it? It's going to be n minus k plus k divided by 2. That's going to be n by 2, right? So n by 2 is greater than equals to the square root of this, or in another sense, n by 2 whole square. It's going to be greater than equals to this multiplication term. So this will reduce to big of n square, right? And what will be the case when it will be equal to big of n square? Like basically em equals to gm. That condition is x equals to y. Basically n minus k equals to k. Everybody got it till this point? Oh, okay, so like if you're stuck in finding time complexities, just write it down mathematically and try to deduce it. So this term, like this term actually, this term will have the worst case time complexity of n square by 4 when k equals to n by 2. And in that case, like we have the range of n equals to, like let me see the question, 10 to power 9 probably, 10 to power 5 I mean. It was 10 to power 5, as much as I remember. So basically 10 to power 10 will go to 1000 second, or maybe more than that, depends, 1000 approximately, because 10 to power 7 iterations make it 1 second. So the if you see, the time limit was of 1 second, and obviously 1000 second is like impossible, next to impossible to in any ID. It's gonna give you a time limit error. So that for that test case, your solution would have failed. But since it was an error from our side, we didn't rejudge it. So it's for everybody who thinks that there might have been a simpler approach. It is wrong. You have to use a multiset. You have to use a priority queue, or you can use a map. Okay. Okay. If anybody has a doubt, please tell me. I'll address it. Okay. I will move on to the next question. So the second question, and this was scientists versus mathematicians. So basically, here you are dealing in damage of X, and the actual damage that the scientist receives is X plus GCD of AI minus X. I mean his health point minus X. If the health point is greater than X or X otherwise, and he can be dealt only a single blow. So in a single blow, you have to kill him, right? So you have to minimize this sum of the damages that we are dealing. So again, this is a very mathematical question. Like here, you can have two approaches. First is not approach, like two ways to solve the question. So either you're gonna have a mathematical deduction, like you can derive it mathematically, or you can just like give a guess, have a nice tukka as we say. So basically, we know that we are dealing in damage of x plus GCD of, I'm writing in G of a minus x comma x. Let's take the case when a is greater than x. Okay. So here now we have to make this greater than equals to a, right? We have to make the damage greater than equals to a. That's when the monster, the scientist, will be killed, right? So let's suppose this is equal to k. This is equal to k, and this is equal to a minus x. GCD is equals to greater than equals to a minus x. K is greater than equals to a minus x. So now because this is the GCD, therefore k modulus x is gonna be 0, and k modulus a minus x both are gonna be 0. So we can write k equals to, or actually x equals to, x is gonna be p1. Let's suppose p1 is the factor, p1 times k, and a minus x is gonna be p2 times k. Okay, everybody got it till this point? This is just the mathematical deduction I wanted to show you to prove the formula. So right, x equals to p1k, and a minus x equals to p2k, and we have, because this is not this cannot be x equals to 0. X cannot be equals to 0, and a minus x cannot be equals to 0. Okay, so we have p1 and p2, greater than equals to 1. We will require to use this condition later on. I will show you. This is an important condition. P1 and P2 are integers which are greater than equals to 1. Okay. So now what we can do is, we can write a minus x is greater than equals to P2 of a minus x. Can you tell me why? This is the main thing. and this both this encircled points. These are the main things. K is greater than equals to a minus x. Therefore, a minus x equals to p2 times k. It is greater than equals to p2 times a minus x. Does anybody has a doubt in that? Okay, I think not. So here you can see that p2 is less than equals to 1, right? Since a minus x is not equals to 0, we can divide it. We can cut it. This will be divided 1 times. So p2 is less than equals to 1 and p2 is greater than equals to 1. What is going to be the value of p2? Anybody? You can turn on your mic. What's going to be the value of p2? Okay, I know that you know the answer. You're just not telling me. P2 is equals to 1, right? P2 is equals to 1. This is the uh, derivation I did. Now we have x equals to p1k. So wait, p2 equals to 1, and then so we had basically the a minus x equals to k. Uh, a minus x equals to k. We got it. Okay. A minus x equals to k, and what was k? Please explain how you got greater than equals to p2 of a minus x. Okay, so let me explain it again. A minus x was equals to p2 times k because the k is the GCD and GCD is a factor. So obviously, when you divide a minus x by a factor, it's going to be a constant integer. It's going to be divisible. A minus x is going to be divisible by k. So I wrote a minus x equals to p2 times k. You got it? And what was k? K was GCD, and GCD had to be greater than equals to a minus x. Why? Such that we are killing the monster, killing the scientist. Okay. So basically, a minus x is greater than equals to p2 times a minus x. That gives p2 is less than equals to 1. And we already had p2 greater than equals to 1. So that gave p2 equals to 1. So a minus x is basically equal to k. And what was k? K was the GCD. A minus x equals to k. Okay. Now there was a minus x equals to p2 times k. Now x equals to p1 times what was k? We can directly write k equals to a minus x. Okay, let me write it below. X equals to p1 times k equals to p1 times a minus x. Wait a second, a minus x. I know this is a bit lengthy, but to prove it, I have to do it. Does anybody have a doubt in this? How I got x equals to p1 into a minus x? After this, it's quite simple. Okay, so basically after this, what are you gonna do? You're gonna simplify the equation. We get x equals to 1 minus a upon p plus 1. Okay, we get x equals to 1 minus a upon p plus 1. A is a constant, 1 is obviously a constant. This is p1, and this is gonna be a this is gonna be a constant number. This is gonna be integer. So what should be the value of p1 up plus 1? Oh, this is gonna be a actually. What should be the value of p1 plus 1 such that x is minimized? It should be the largest factor of A, right? I'm writing this as okay, smallest, actually smallest, because we are subtracting it from A. So to decrease x, we need to increase A upon P1 plus 1. Therefore, we need to decrease P1 plus 1. So this needs to be the smallest factor, or in another sense, smallest prime factor, which is called SPF. Anybody heard this term SPF? It is quite useful in CP. So basically, like, if you're gonna see the test case, I'm just gonna prove you, like 19 and 25. For 19, we took, in the example, we took 18. So what is the smallest prime factor of 19? It is 19 itself, because 19 is a prime number. So 19 minus 19 divided by 19 is going to be 18 for x equals to 19. And for 25 is going to be 25 minus 25 divided by 5. That's going to be 20, right? So basically we got the answer 38. Now how to implement it, that's another uh, question. For your sake of simplicity, I gave the time complexities, time and complexities basically of AI. I gave it 10 to power 4. So you can easily calculate the number of prime factors of AI up to 10 to power 4, right? From 1, 2, 3, 4 up to 10 to power 4, you can do it. And then after that, you can just find the minimum prime factor of all of them. Like, let me show you the code. Okay, this is the code. So basically, we are calculating the SPF, SPF of that every AI, and then we are subtracting A minus A divided by SPF. That's the logic. So how you implement SPF, that's up to you. But I think you can do it. You can easily do it because the complexity is constraint is quite low, 10 to power 4. You can easily do it. And then there is just an edge case of AI equals to 1. When AI equals to 1, if you are going to use this formula, it's going to give you an error, because like where was it? Because like the SPF of 1 is in, if you like 1 is not a prime number, there is no SPF of 1, but like if you calculate it, it's going to come out to be 1. Yeah, here has shared a blog about SPF. So if you take the case of 1, the P1 plus 1 is going to be 1. P1 plus 1 equals to 1, and P1 is going to come out to 0, which is not possible because P1 has to be greater than or equals to 1. So basically we're handling AI equals to 1 as an edge case. We're just simply adding 1 to it, right? So nothing to think about AI equals to 1. Otherwise, you have to add AI minus AI divided by SPF of AI. Okay, that's the question. We will share you the blog about SPF in your WhatsApp groups as well. It is quite a useful technique. Like if I give the constraint to be 10 to power 6 or 10 to power 7, then you cannot do it through the normal prime factor calculation. You have to use the SPF algorithm, sieve algorithm actually. From there we get the SPF. There's a technique. It is going to be too long for me to discuss it here. You can just better watch a video. We will share the links. So that was the question basically. If anyone has a doubt, please tell me. I'll be glad to answer it. Okay, I'm moving on to the next question.
Excuse me, भैया.
हाँ बताओ बताओ.
भैया जैसे इसमें एक वो था ना कि जीसीडी ऑफ ए माइनस एक्स एंड एक्स इट्स गोइंग टू बी ए माइनस एक्स, है ना?
इट्स गोना बी ग्रेटर देन इक्वल्स टू a minus x.
हाँ, तो फिर हमने बाद में प्रूव कर दिया था ना कि वो एक्चुअली इक्वल टू आ जाता है।
हाँ हाँ हाँ, ठीक है ठीक है.
हाँ, तो अगर जीसीडी ऑफ ए माइनस एक्स और एक्स इज इक्वल टू ए माइनस एक्स, तो एक वो होता था ना जीसीडी का एल्गोरिदम, जिसके हिसाब से वो माइनस करते रहते थे मतलब लूप में, और अगर एक वैल्यू जीरो आ जाती थी तो दूसरी वैल्यू जीसीडी होती थी।
एक वैल्यू 0 0 या मतलब जीसीडी निकाल रहे हो तुम बेसिकली.
हाँ हाँ, मैं
अच्छा अच्छा
जीसीडी
अच्छा अच्छा
निकाल रहा
अच्छा
हूँ।
अच्छा ए माइनस वो जो जीसीडी निकालने का जो मतलब फॉर्मूला है.
हाँ जी।
अच्छा अच्छा हाँ हाँ.
तो अगर मैं वैसे करूँ तो उस केस में अगर मैं मॉड्यूलो निकालूँ ए माइनस एक्स का एक्स के साथ, तो
हम्म.
अम, तो बेसिकली वो एक्स ज़ीरो आना चाहिए ना, मतलब ए माइनस एक्स मॉड्यूलो ए माइनस एक्स शुड बी ज़ीरो नहीं?
क्या क्या प्लीज रिपीट.
जी सी डी ऑफ ए माइनस एक्स कॉमा एक्स, अगर मुझे इसको इक्वल करना है ए माइनस एक्स के,
हम्म.
तो एक्स मॉड्यूलस ए माइनस एक्स इसकी वैल्यू ज़ीरो नहीं होनी चाहिए?
x modulo a minus x equals to 0.
हाँ जी।
Okay, basically you're saying gcd of a comma b equals to a. मतलब ये तो दो अलग अलग नंबर्स है ना, a minus x और x है, वो इक्वल्स टू a minus x है, तो उससे मतलब कैसे इक्वल्स टू 0 आ गया? नेसेसरी है क्या? 9,4 तो तुम बोल रहे हो दैट मींस कि x मॉडुलस a minus x इक्वल्स टू 0, वो बोल रहे हो ना तुम?
हाँ जी।
इक्वल्स टू 9 gcd of a minus x should be greater than a minus.
हाँ जी।
क्या लिखा विक्रम ने? gcd to be a minus x, gcd should be greater than a minus. X should be greater than a minus x because a minus x is a factor. तुम ना थोड़ा मैं कैच कर नहीं पा रहा, तुम बता दो मतलब x मॉडुलस a minus x इक्वल्स टू 0 कैसे आ गया? यूक्लिडियन थ्योरम. अच्छा अच्छा.
हाँ भैया, वो जीसीडी का एक थ्योरम नहीं होता था यूक्लिडियन एल्गोरिथम करके?
वो तो मतलब उसको वाइल लूप चलाते थे ना, उसमें उसमें तो मतलब
हाँ, वाइल लूप
कोई
चलाते थे,
प्रोसेस है.
बट लेकिन सिंस यहाँ पे ए माइनस एक्स और एक्स का जीसीडी हमें पता है कि ए माइनस एक्स ही आने वाला है, उसमें मतलब ऐसा होता था ना कि अगर दो नंबर का जीसीडी हमें निकालना है, लेट्स से 9 और 4 ही है, ठीक है?
हम्म.
तो हम जो भी बड़ा नंबर है, लेट्स से 9 यहाँ पे बड़ा है, 4 छोटा
फिर
है,
स्वैप
तो
कर देते थे.
हाँ, फिर हम उसे सब्ट्रैक्ट करते रहते थे, तो 9 में से 2 बार ही 4 सब्ट्रैक्ट होगा तो बचेगा 1। तो फिर अब 4 को सब्सिक्वेंटली फिर वो सब्ट्रैक्ट करते जाएँगे रिपीटेडली, तो वो 0 आ जाएगा, राइट? तो सिंस 4 0 बन चुका है अब, तो इसका जो जीसीडी होगा वो पहले वाला नंबर होगा, दैट इज़ वो जो 9 जो 1 बन गया था, तो 1 जीसीडी हो
हम्म.
जाएगा ऐसा।
हम्म.
तो अगर मुझे पता है कि इसका जीसीडी 4 ही आने वाला है, तो मैं ये बोल सकता हूँ ना कि लाइक जो ये वाला नंबर होगा दैट इज़ कि एक्स मतलब जो 4 है बेसिकली, वो बाद में एट द एंड 0 बन जाएगा सब्सिक्वेंटली सब्ट्रैक्ट करने के बाद, अगर मैं बार-बार सब्ट्रैक्ट करूँ उसे तो, ऐसा।
एक बार a minus x आ गया, उसके बाद
हुँ।
मतलब बार बार सब्सट्रैक्ट करने के बाद एट द एंड मतलब वो a minus x ही रहेगा, वो बोल रहे हो तुम है ना?
हाँ, a माइनस एक्स एज़ इट इज़ रहेगा और x 0 हो जाएगा ऐसा।
ओके, मैं एक बार
तो
ये
इस
देख लेता हूँ, फिर अभी नेक्स्ट क्वेश्चन में जाते हैं. मैं तुम्हें व्हाट्सएप ग्रुप पे ऑफिशियल ग्रुप पे बता दूंगा एक बार, क्योंकि सबका टाइम
ओके,
वेस्ट हो रहा है ना, नहीं तो.
ठीक है।
ठीक है ठीक है. मैं भी एक बार प्रॉपर्ली देख लूंगा. ओ, geology is somehow larger one just gave it. हम्म. एक बार मैं चेक कर लूंगा, वेरीफाई कर लूंगा एक बार मैं. फिलहाल के लिए डी को एक बार देख लेते हैं. So D was simply based on binary search. If you know binary search, then it's going to be really simple for you. So I can just show you the code actually. So basically, you needed to you were given different gases, and and in each second there is a deduction of 1 points in the health, and the gases start at 8 second. Here is given to you in an array. So what you need to do is that you need to find a minimum value of k such that gas will cause at least h damage to the aliens. What is k? K is the time for which the gas will each of the gas will be lingering at the atmosphere. So I can just show you the code actually. It is best to show you the code. So first of all, you okay? I'm gonna show you the intuition. Okay, it is loading. So basically, what we needed to do is like we know that the constraint is 10 to power 5. The constraint is given to be 10 to power 5. Actually, 100. 100 into 1000 is going to be 10 to power 5. N is not bounded. So 1000 into 100 is going to be 10 to power 5. Worst case of t into n. And AI is given to be 10 to power 9. So we can know that if you're going to use binary search, we can run a for loop of n times for each test case, and log n is always going to be like maximum big of 100, so it's going to come under 1 second, and it's going to come under 10 to power 7 iterations. So what I did was that first I sorted the array, because we need to apply binary search on an array only when the array is sorted. Only then we can apply binary search, right? So like this is the implementation. I started the minimum value of k equals to 0, right? It can be 0 or it cannot be, doesn't matter. It's not going to be negative basically. So minimum value is 0, and the maximum value is going to be h. Can you understand why the maximum value can be h? Because if it is h, then at least for the last value of ai, we are gonna have that last value lingering, last guess lingering on for exactly 8 seconds. So the total damage done is gonna be greater than or equals to h. So the maximum value of k is going to be h, and the minimum value of k is going to be 0. Everybody got that? So after that, it's basically a simple binary search. While high minus low is greater than 1, we took the mid. And this is important, that greater than equals to sign. Because like if you are given equal, what we need to find? We need to find the minimum value of k, right? So if we are given like 5, 5, 5, 5, 5, we need to reduce the search space in such a way that we are including the leftmost element of the 5555 subsegment, right? You understand what I mean? If there are lots of equal numbers in the subsegment and we need to reduce it, we need to find the minimum of the values, not the maximum. So it's like doesn't matter that much. Basically, we checked once for low. If low is the answer, we print low. Else, we print high. What's going to be the time complexity? For binary search, this while loop is going to run for a log base to h times, right? Log base to h times, and the function that is called, each time it is going to run for n times, and whole it is t times. Everything is running t times. So 1000 into 100 into log base to 10 to power 9. It's gonna come under 1 second. So that was the simple implementation of this question. Does anybody have a doubt in this? How do you calculate time complexity required from input range? Okay, for from input range, like what do you mean? Like what should be the expected time complexity, right? So you can just say that you're given 10 to power 5. So from 10 to power 5, you can run it n times. N times it is going to run. And after that, if you gonna use a binary search or sorting algorithm, then it's gonna give you an additional multiplication of log base to n or h, whatever. So what is log base to 10 to power 18? It's approximately 64. So 64 is comes under big of 100, right? So basically 10 to power 5 into 100 is 10 to power 7. It's gonna come under 1 second. Here it was not exactly 10 to power 5. It was 1000 into 10 to power 2, right? We know in 1 second you can do 10 to power. Yeah. Anybody else having a doubt? You can ask me anything, like anything related to like time complexity and all. It doesn't have to be related to the question. If you are finding difficulties understanding time complexity, you can ask me. Okay. Iftikar? Here, তুমি কৰি আছা?
Hello, am I audible? Hello. Hello, is my screen visible? Hello. Hello. Sound is clear. Hello.
Okay.
Okay, so let's see the last question. So what does the question say? So basically, you are given a tree, like, and and you will be asked Q queries, and for each query, you have to like tell me the of of the value of each node in the path from U to V. So if we look at this tree, so this is a simple tree with each node has a value 1 2 3 4 5. Let's say in a query you are asked 2 comma 3, so you have to tell me the sum of this value, sum of the value of the nodes which like lie in the simple path from 2 to 3. So here from 2 to 3 there is only one path, this, and sum of this will be 2 plus 1 plus 3, which is 6. So basically that's the question, but you have to tell this for Q queries. So if like you have to tell this for only a like simple query, then it will be simple, like you can directly start a DFS or BFS from here, and until you go until you reach this node, and then you can tell the sum. But in this question you are asked Q queries, and like Q value of Q will be 10 to the power 5. So and like for each query, uh, let's assume the worst case. So if I ask the like sum of the path from 2 to 5, so it will be like complete like if the, let's assume the tree is like this. Okay, so and for each query you are asked the like summation of sum from in the path from 1 to 5. So for each query you have to traverse the entire tree, right? And like for q, like there are n nodes, and like a maximum value of q can be up to n. So like it will go n square, like which will easily show us like time limit. So we have to come up with another idea. So okay, now for this tree, like the given tree is not rooted, right? Rooted means like the tree is you can say like if this tree is rooted at this node 1, then you can say 1 is the then 1 is father of 2 and 3. Similarly, 3 is father of 4 and 5, and like 2 and 3 will be like uh, children of 1. So rooted means like this will be the like this will have no parents, and every node will be like a descendant of this node. So let us assume the given tree is rooted at any node. For this example case, like I'll assume that this is rooted at node 1. So now if we can see, let's suppose we need the like sum from part 2 to 3. So what can we do? We can calculate the like sum from 2 to 1, and again 3 to 1. Then we can both add this, and this one will be calculated twice. Like from 2 to 1, the sum will be 3, and from 3 to 1, the sum will be 4. So it will be 7. But here you see like 1 is calculated twice. So we have to remove 1. So it will be 6. Right. Let's assume one more case. So like suppose again we are asked from 4 to 5. So if we consider like 4, what is the sum from 1 to 4? It will be like 1 plus 3 plus 4, which will be 8. Then again 1 to 5, which will be 9, and this will be equal how much? 17. But if you see 4 to 5, the sum uh, yeah, will be like only 12. So this is like wrong. So uh, for the last case we are like subtract only this value, but for now we have to subtract this entire value, because when we calculate the sum from 1 to 4, we are calculating this. Again 1 to 5, we are calculating this. So we have to remove, we are calculating this part twice, but this part is not included in the part from 4 to 5. So we are going to remove 4 twice. So 17 minus 4, 17 minus 4 will be 13. But if you like in 2 into 4, we are removing this twice. So 17 minus 8 will be 9. Okay, but if you see this sum come up to be 12. So we are like when we are removing this first part, then only 4 remains. Again when we are removing this, then only 5 remains, and we are not considering this node. So we have to add this again, so it will be 12. So if we like see this again, so we can say like we can say we the our first step will be to calculate the sum from root to that node, or root to both node. Let's say like a vector represent a of I represent the sum of path from this root to ith node. Okay, sum from 1 to I. So if we see, then this then like sum from A to B will be what? Distance from 1 to A plus like we are considering x1, suppose A of x plus A of y, then will be like, and this node will call lowest common ancestor. For like 2 1 is an ancestor, right? For 4 3 and 1 is an ancestor, and for 5 3 and 1 is a ancestor. So lowest common ancestor will be 3. So we'll be removing distance from root to this lowest common ancestor, and again we are adding the value at that node. So like value at LCE. So our solution will be this. But now like our like main task will be to how can we find the sum from root to that node at like constant time, and how can we find the LCA of this two node at like constant or log n time. So again let's take one more example in this tree. So if we consider like what will be the LC of 8 and 7, anyone like what will be the LC of 8 and 7? Yes, because if you see like the ancestor of 8 are 4 3 and 1, because I am considering again 1 is the root. You can consider anyone, but for simplicity I am considering 1 is root. So like ancestor of 8 will be 4 3 and 1, and ancestor of 7 will be 5 3 and 1. Like who is the common ancestor at lowest? So 3 will be. So again the summation from summation in the part sum of the like value of nodes at part from 8 to 7 will be how much? Like summation of uh, part from root to 8 plus summation of part from root to 7 minus 2 into summation from root to LCA. LCA is 3 plus value at 3, which is 3. So uh, like 1 plus 3 4, like I'm calculating the value from root to every node. So this will be 1, this will be 1 plus 2 is equal 3, 1 plus 3 is equal 4, 4 plus 4 is equal 8, 8 plus 8 is equal 16, and again 4 plus 5 is equal 9, 9 plus 7 is equal 16, 9 plus 6 is equal 15, 15 plus 9 is equal 24. So if you see a of 8 will be 16 plus 16 minus 2 into a of 3 will be 4 plus 3. So this will be 16, 16, 32. 32 minus 8, 24 plus 3, 27. And if we like see 8 plus 4 plus 3 plus 5 plus 7, 12, 12, 15. 15 plus 12, 27. So I hope like our approach is clear. Like let's forget about the implementation of the part, how you calculate this value and like the LCA. This part is clear, right? Okay. Now for calculating this value, it will be like really simple if you know like basic tree. Then like you can implement a DFS, right? So like if we start the DFS from this node like root, then we can like write a of like every child will be equal like value at the child plus uh, distance of like like this means like for every child the value of a of this child will be its own value plus the distance from root to its parent. So if we like for root, there will be no parent, right? So like this value, so this value will be 0 for the root. So like for root, this will be like v of value of root 1. So like for 3 it will be like 3 value of child, which is 3 plus a of parent, which will be 1. So this will be 4. Then again for this node, value of the child, 4 is the child, so value of the child will be 4, and like its parent is again 4, so 8. Then like it is a simple DFS if we like look at the code. So like uh, ignore ignore this all stuff. Like this is the simple DFS. Okay, this is the DFS, and like ignore this and like basic DFS, like this for loop. I am calculating the this part is calculating the what we call like a of, but a is what sum from root to that node, sum of all the nodes in the path from the root to u. So this will equal, where v is the parent, right? A is, u is the children of v, so a of u will equal a of plus equal same a of v. And here I am not considering this term because I am initial. What is a? A is already. You see, I have a is what the like this array. Okay, so I am already like initializing a of child with v of child, so we can ignore this path because a is equal v. So a of child will be is plus equal a of parent. Okay, so calculating this value, like I guess is calculating this value, I guess is clear. Like if anyone have any doubt on like calculating the k vector, like if you have any doubt, okay. So like uh, now how will calculate the LCA? So for LCA we will like use a like beautiful method, like e- create ith parent of u is what, like I minus one parent of I 2 to the power ith parent of u is what, like it will be equal 2 to the power I minus 1 parent of 2 to the power I minus 1 parent of u. Like basically what is the third parent? Third parent means like level 3. uh, for like 9, first parent is 6, second parent is 5, third parent is 3, fourth parent is 1. Okay, so like what will get third parent of u? It will be, you can say like it will be the first parent of second parent of what, like u. Like it's basically you are dividing it, but in this way we can like use, like if we always consider this as e to the power k form. Like like for every number k you can represent it as like summation of e to the power I into, so like b where like b equals 0 or 1, like I equals for 0 to if like k is less than 10 to the power 9, you can say 30. But in this question k is, I guess, is to the power 5, so you can say approximately 20. So this is like a binary representation of any number. So we can like always represent the number as a sum of whose power. Okay, so we'll use this method. So we can like uh, for again let's suppose this is a tree. 4, 6, 7, 8, 9. So what will be the like fourth parent of 9? Fourth parent of 9 will be the 9 will be equal to 2th parent of 2th parent of 9. What is the 2th parent of 9? Is 6. 6 2th parent is 2, and 9 fourth parent is also 2. So now like if I need to find the like LCA, lowest common ancestor of, let's suppose 2 and 7. So I'll check if 7 is the ancestor of 9 or not. If yes, if 7 is already ancestor of 9, then it will be the lowest, right? Suppose 7, 8, 9, and there's like 8. So like if here 7 is the ancestor of 9, right? So the lowest common ancestor will be 7 itself. Okay. So first we check is 7 is the ancestor of 9. So right, because like clearly like from the picture. Then again we'll see check if 9 is the uh, ancestor of 7. No. Okay. Now we will check if like 9 8 how do I say, if say fourth parent of 9 is ancestor of 7 or not. If yes, we'll do nothing. Okay. Then again we'll see 4. Then 2th parent of 9 is ancestor of 7 or not. Okay. Okay, like first I'll clarify how we'll check one node is the ancestor of another one, like in like constant time. So when we run a DFS from a tree, right? 4, 4, 5, and 6. So when we run a DFS from a tree, we'll assign like when we enter the node and when we remove the when we go out from the node, like exit from the node. So we'll assign a time. Let's suppose I am starting the DFS from 1. So I am assigning like entry time is 1. Okay, then I suppose go to 2. So entry time of this will be 2. Like every time I am increasing the timer. Then again for 4, entry time will be 3, and again from 4 there is nothing to go, so I'll go out. So the exit time of 4 will be 4. Then again 2, from 2 I am going to 5. So entry time is 5, then exit time will be 6. Then from 2 there nothing else to go, so this will be 7. Then again from 1 I can go to 3, so this will be 8 entry time. Then again this will be 9 entry time. Then 10 will be here exit time, 11 will be exit time, so 12 will be exit time. So if you see, if a node, I will show you this function in my code, is ancestor. Like if u is the ancestor of v or not, when u will be ancestor of v, when like you enter u before v and you leave u after v, which means like entry time of u will be less than entry time of v, this part. And again exit time of u will be greater than exit time of v. So for like using this I am going to check uh, if u is a ancestor of v or not. Okay, now again come to the LCA part. So I can like easily check, right, is 2 is the ancestor of 9 or not. So 2 is not an ancestor of like 2 is ancestor of 7 or not. If yes, we'll do nothing. Again we'll say 6 is an ancestor or not of 7. Again 6 is an ancestor of 7, so we'll do nothing. Then again we'll 6 8 is an ancestor of 7 or not. If not, then we'll find the ancestor of 7 and 8. Okay, this part is clear, right? Let me go through again. Let's suppose I have to find the ancestor of uh, this 7 and 9. So first I'll lowest common ancestor of 7 and 9. So I'll check first like is I have to check like first eighth parent since it doesn't exist. So I'm gonna check is like fourth parent is the ancestor of 7 or no. Is fourth parent not fourth ancestor? The fourth ancestor of 9 will be 2, right? So 2 is also is ancestor of 7. So we'll do nothing. Again, we'll say that 2th ancestor of 9 is an ancestor of 7 or not. If yes, again we do nothing. Then again we'll say check if uh, first ancestor of 9 is an ancestor of 7 or not. Yes, no, it's not an ancestor. So now we have to find the ancestor of 7 and 8. Okay. Mm. So this part I am for finding the LCA. Okay. For finding the LCA, I am first checking like is it all U is already an ancestor of V. If yes, then U will be the LCA. Same if V is already an ancestor of U, then V will be the LCA. Otherwise, I am checking is what is this U this term is equal to the U to the power I ancestor of U. Okay, like when I say for I equal to, I am checking fourth ancestor of U, like fourth ancestor of 9. So see if like is not an ancestor, is if is an ancestor, then it will return true, but there is a like not sign, so it will be false. So we'll do nothing. Then at last we'll see when it is not, when like 8 is not an ancestor of 7, right? So we'll replace U with 8. Okay, then again we'll go if this is a ancestor of uh, like uh, we go I equal 2 or 9 and 2. 2 is an ancestor of 7, we'll do nothing. When I equal 1, 6 is a ancestor of 7, so we'll do nothing. When I equals 0, then 8 is not an ancestor of 7, so we'll replace u with 8. Okay, now this loop is finished. So we'll come out of this loop and we'll return the 2 to the power 0th ancestor of current u, which is first ancestor of 8, which is 6. So this will be LCM. Now how did we calculate this? Like this is a standard approach called like binary lifting. Like it is a little complex to explain in this like uh, easily, so I'll recommend you to like go and like watch it on YouTube or read any edit like blog about this in CP algorithm. But I'll give you a simple idea. Like this is this line, like 2 to the power I ancestor of V is nothing but this one. 2 to the power I parent of U is nothing but 2 to the power I minus 1 parent of 2 to the power I minus 1. So if you see this part, this is like what 2 to the power I minus 1 ancestor of ancestor, this is V, sorry, ancestor of V, right? And it's again 2 to the power uh, it's again 2 to the power I ancestor, I minus 1 ancestor. And for the base case for every node, like e of e comma 0 is like its parent, right? Because 2 to the power 0th ancestor is of course the parent. So I am assigning this, and then I am calculating this from the for loop. So now the like this is the final part, like which I explained in the beginning. Like now I can like find LCA in like almost log n time. From again I can find the distance from root to any node in constant time. So I can find the like sum of path in A to B in like A of x. X y will be A of x plus A of y minus 2 into LCA of E of LCA plus value of LCA. So this is big of 1, this is big of 1, this is big of log n, and this is big of 1. So like overall complexity will be u log n. And like for building this array, it will take n log n time. So n log n plus 2 log n, which q can be n. So like overall complexity will be n log n. And our like basic idea is to like find the LCA like using binary lifting. Then uh, sum from root to that node plus sum from root to the other node minus 2 into root sum from root to LCA of this two node. And then again we are like finally adding the value of the LCA. So this is the solution. If you can see, like this is all for like calculating the t in t out. This is all for the like ancestor and binary lifting part, which is normal DFS, like, but I'm keeping track of a timer. Then again I am calculating the like making the array for binary lifting, then again adding the sum, like slightly modified DFS. And then this is ancestor checking function, and this function is to find the like LC of this or LC of the of any two node. Okay. So, or like if anyone have any doubt about like uh, I suppose it will be like hard for you to like understand this in the like if you are not familiar with pre or any DFS. It's like pretty like advanced topic in tree, but you get the idea, right? Like when we have to like find the uh, like this part, find that like ith root of ith ancestor 2 to the power I minus 2 to the power ith ancestor of any node is equal to the I minus 1, then again 2 to the power I minus 1. So this is the main idea behind like binary lifting. So like you can see like for like suppose like this is a tree, there are multiple nodes, and again there's this. Okay, so now I have to find the ancestor. I'll like first check this is the ancestor of this, yes. So I'll not check this, not check this, not check this. I'll see the midpoint of this. I 2 to the power I by 2 is equal to the power I minus 1. So I will check the midpoint 2 to the power I minus 1 is like suppose this is the is this is the ancestor. If yes, then again I'll check the mid. If this is the ancestor, then again if this is not, then I'm like assigning this. I'm finding now LC of this node and this node. Again, now my like searching space will not be from here to here. It will be from here to here. So like again I will be checking if this is the ancestor. And we go like at the end, like I have to find like tree will be like this. Now I have to find the ancestor of this is same, and this node will like come to be this, and like I will be 0, so it will come out of the loop, and its parent will be the like lowest common ancestor of this and this node. So this is like, like if you have any doubt at all, or like did you like not totally like completely like you are not able to understand it. So like if you don't have any doubt, like so we should like end the discussion now.
एंड कर दे क्या मीटिंग?